This conference will now be recorded.
Okay, so today we are going to spend time on Docker. So today we'll learn Docker. So the first question we should have in our mind, and that is like, what is Docker? Correct? What is Docker? So when I look at this tool, I find it Docker is nothing but it's managing containers. So you can simply say it's a container management tool. Okay. Now, when we say management means what? Tool means what? Container means what? So these are the things which we need to understand. So here, when we say tool, this will uh, any tool if you use it in the world, okay, it will save time. Correct? That is important. It will save cost. Correct? And then it will help you to, in terms of improving quality of work as well. So that's the reason we use the tool, right? We change the tool nowadays very often because of these other reasons. Everyone wants to save a time, save cost, and improve the quality. So you should ask like how these containers or Docker will save my time. So it will save a time in terms of let's put it in this way: save time when you want to run your applications in the physical server, right? Physical server, then how much time it used to take. Remember that. You'll get an idea. And then you set up applications in the VMs, virtual machines, right? Using cloud or hosted environment or something. How much time you spend for setting up the application and running application. It's all about applications, okay? You want to run applications. Thousands and thousands of applications you want to run. Thousands of Apache you want to run. Thousands of Tomcat you want to run. Thousands of SQL you want to run. So how much time it takes to run? But when you run application in a container with a Docker, it will take 1 seconds. So here it's probably is taking 5 minutes if you want to set up, and here probably it will take 1 day to configure the server, physical server. So this is how the you bin transitions. So when you use containers, you can run applications in a no time. How? This I'll show you through demo. Okay. So that's one of the reason why we are doing this. Now, in terms of saving cost, how it can save a cost. So when you run application, it consumes CPU, RAM, disk, and operating system cost apart from applications. So now if you run application in a physical server, you will have to spend so much amount of CPU, RAM, disk space, and operating system. In virtualizations, you know that you have to pay a little bit of virtualization cost also. But when you run application using container, then you are spending less CPU, RAM, and no operating system cost. So that way, running application within a container is very beneficial and cost saving in terms of, let's say you want to run thousands of Apache. So thousands of virtual machines you have to create versus thousands of container you have to create. So container is lighter. Lighter means it's consume less CPU, RAM, and no operating system. So that way it can save your cost as well. And ultimately, if something is saving your time and cost, so you will get a more, you know, resources to focus on the quality. Correct? So if someone will ask you, hey, why we are migrating to containers or Docker, I think, did you get idea why we are doing it?
Yeah, Rajesh, I mean, it's a cost saving, infra saving.
Yeah, time saving and so. Now next question is like, okay, so I got the benefit, but how Docker is managing container. So when you call it a management, basically using Docker, I'm simplifying this. Using Docker, you can create a container. You can start a container. You can stop a container. You can restart container. You can pause container. You can unpause container. You can kill container. You can remove container. So these all things what you want to do with a container, you can do using Docker. Simply, I'll put it in a conceptual way. Let's say if you're using VMware, what do? You create a VM, you start a VM, stop a VM, restart a VM, pause, unpause, kill, remove, all this thing you do that, right? Same thing using Docker, you can do all these activities with container. So now the most important question is what is container then? Okay, what is container? So now if you want to understand what is container, you need to go a little bit into the how kernel works, and you need to go a little bit of understanding the resources required for running any applications. And when I say understand this container, in order to understand the container, you need to understand resources required to run applic and applications. So this is the answer. If you find an answer for this question, you will understand container very well. Now, when we say resources means what? Everything, whatever is required, we'll discuss in some time. An app means what? So I want to show you some of the processes. Let me in Windows, right? See that how many applications I'm running. See that here. Something you can see in Windows also, Linux also, PS table and all. Right? These are the applications I'm running. Right? I would like you to spend some time and there is a detailed view. Here it is. Yeah. So I want you to look at this here. What are the resources we required? So here, if you look at the table, these all are applications I'm running or system is running. And then in order to run these applications, each applications, if you look at this, they have a associated PIDs, correct now? Unique PIDs. This is the, you can say, the process identification number. Using that, you can identify which process. And also, if you look at it, each application is running by some user. Carefully, if you look at this, correct now? Some of the users is run by me, some of the users run by system user, some DMW users, and so on. And if you look at it very carefully, each application is consuming CPU and memories. Correct now? Right?
Yeah.
There is one thing which I cannot locate. I can find out the user, I can find out the PID, I can find out the CPU memory. Two things I cannot see here in this image, and that is a disk, which let's say this image, I mean this applications. So if you want to see the utilization of disk, let's say, so fast it's going. So here, if you go to the properties, this is the location they have consumed. This is the disk space, their location, actually mount location, you can say. This is the disk. And one thing which is not coming in this image as one more thing, which is network. Network means most of the applications is console based right now, but let's say some applications required network address. For example, Apache, which required 80 port to be on run, right? It runs on the port number, right? Tomcat run on 8080, MySQL some 3306, something like that. So network resources also required, right? So these are the resources you need to run an application. So here I would like to draw some pictures in easy way, though slides will be time consuming. So if you want to define this, let me use the online tool actually. So yeah, so if you want to define this, let's put it in this way. This is your hardware, okay? And on based on the hardware, what we do, uh, then we have operating system, correct? Operating system. Now, this operating system, typically you have a kernel. Agree with me?
Yes.
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 Yes. So you have a kernel. And then after that, once you have a kernel, then what we do is like this kernel create a few resources. One of the resources we created by kernel is mount. When you say mount, mean file system, root file system, like C drive, program files, Windows in Windows and in Linux, OPT, bin, user, all this thing. Mount is created, disk mount. We call it mount in computing terminologies. And then one resources is being created uh, by kernel, okay, and that is called network. And there's one resources also we created bit tree which assign the process ID to each processes, right? So if you look at this kernel is creating mount, network, and bit tree. And then here one more resource is being created, which is user, and you can create a multiple user, one user, two user. See here in this image also multiple users are there, right? So multiple users, and then users is running an application. So this is application 1 and this is application 2. Now the most interesting part is this application is getting the PID from this using the same network and same mount, probably C Apache A, C Apache B, something like this. This application using same bit, same network, same mount, right? Are you agreeing with it?
Yep.
Yeah. So here when I say, hey, the question was what are the resources required to run an applications? So you need a hardware, you need operating system, you need a mount, you need a network, you need a bit tree, you need a user, and then you can run applications. So these are the entire resources you require to run applications. Now coming back to the question, what is container? So here what has happened, in a container there is some optimization has been done, okay? So here the guy name, his name is Solomon Hikes. You can see that Solomon Hikes, he's the one he's the one who did some optimizations. What optimizations? So let's understand this. So you're saying, hey, ultimately we want to run applications but cheaper and faster. So what should we do? Let's say we have a hardware, okay? Let's say we have a hardware, understand this, and on top of that you may have a kernel. Now this is the kernel, okay? Now understand this, the kernel you can have on the physical servers also, remember that. And kernels you can have in VMs also. That means VM also contain operating system, full app operating system, right? And physical servers also you can install full operating system. So remember that. Now, kernel has all the capability to create a resources. Which resources? PID, network, mount, and user, which is created here. PID, network, mount, and user. Remember, these are kernel is nothing but the code. So these resources are not a physical resources, they are like a virtual resources. So using code, using the virtual resources, you can create as many use resources actually. You can create PID X number of times, network X number of times, mount X number of mounts, root file system, and users many. So what is happening? By default, in a PC concept, PC means personal computing, the architecture which is used by the humans to navigate and use the computer. In typically they have one PID, one network, mind it, and one mount, and multiple users is allowed. That's architecture. But theoretically, kernel can create as many resources. The idea is what you will do, what human will do with a multiple network, what human will do with a multiple PID tray, what human will do with multiple mounts. When I say multiple mounts means multiple C drive, what you will do, right? Multiple OPT, what you will do. So one OPT, one C drive in one computer is sufficient for human use cases, PC concept. So what Solomon is saying, hey, can we change this architecture a little bit? Whereas kernel is capable to create n number of resources. So can we do one thing? Can we ask kernel, hey kernel, can you create a mount? Let me move a little bit up. Mount. Understand this. Can we create a mount, network, PID tree, and one user, not a multiple user? Okay. Can we create few more mounts, network, PID tree, another user? Can we create a mount, network, PID tree, and another user, network, mount, PID tree, and another user? Can we do that? And that is where the Linus Torvald, who's the founder of Linux, I mean basically Linux, is it says, okay, you want to create multiple resources, and if you are not, creating a problem for the kernel, okay, and there are certain libraries are there, which is available in the market. Again, it's open source. So yeah, using those library, you can instruct. So basically, what has happened here? There's one image is missing in this part. There is one tool has been developed by Solomon Hykes. Okay, this tool is talking to one library, and this library is talking to the kernel and asking to create these resources. Okay, I would like to show you one image actually. Docker namespace, enter. Very popular image. Look at this. Here it is. This is a very popular image. You see here, Docker talk to the container D talk to the kernel. Here it is. Kernel has all the namespace PID, MNT, IPC, UTC, network on blah blah blah. Right? This is a good image. I know. So what is happening here? What is happening here? Can we do that? Then it was allowed by Linux. It was not initially. It was not allowed by Linux, Windows. So what happened? Now we are saying, hey, can we create these resources? Yes. Can we link this user to this all resources? 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 So if you look at this, here you are running Apache. This user, you using this PID tree, this network 80 port, C Apache for OPT Apache, let's say OPT Apache. Here also you are running Apache, some PID ID, and then 80 port again OPT Apache. See here, mount is separate, right? Here, remember that you cannot run two Apache here because mount was same. You have a one network, so you can only run 80 port only once. Here 80 port multiple. See here, and multiple OPT Apache, OPT Apache, OPT Apache, OPT Apache. Now, if you see that very carefully, if you want to run, let's say, 10 Apache in this model, which is VM model or physical model, then you need to have a 10 operating system, correct? Isolation, 10 application isolation, correct?
Yeah.
Now, if you look at this architecture, you want to run 10 like this, you have only one operating system, correct? And still you got the isolation of applications. Are you getting my points?
Yeah, right.
So the
Yes.
question is what is container? This is your container. One container, two container, three container. This container is created by Docker. Docker talk to the container D, which I showed you the image. Container D talk to the kernel and get this all resources running. Ultimately, everything is done by kernel only, remember. But these interfaces which I showed you, you see, Docker talk to the container D. Container D talk to the kernel. Kernel has all the resources. These are the code actually level libraries, PID libraries, MNTs, IPC, UTS, network. And this is C groups for the CPU allocations, memory allocations, device allocations, you know. So it's a part of the kernel, right? So now the question is, what is container? So container, there is a two definition. One is a functional definition. Container is a lightweight application runtime environment. So application means your application. It can be any application you can run, and it's a lightweight. Lightweight means I told you it has no operating system, lesser CPU, lesser RAM, and all da. There is one more technical definition you can say. Container is nothing but it contains one network namespace, one MNT namespace, one user namespace. We call it namespace in kernel terminology, and then one I'm missing it, PID namespace. Okay, and PID namespace. So this is the one network, one PID MNT, and one this one, and this one user is being shared one MN user namespace. So this is your container. Technical keywords. Got it?
Yeah.
Yes. One thing I need to ask regarding this is namespaces, one mount namespace and one PID namespace. So
Mhm.
network we understand, a PID also understand. The mount namespace which you are talking about, can you please elaborate a bit more? What is that one mount namespace?
Good question. So what is a mount namespace? So see here, in this here there is one library, you can call it. We call it in kernel we call it namespace concept. If, just like I'll put it simplify this. So when you have a software, you call it a multiple modules, right? Module, login module, register module, like that, right? So in a kernel, we have a different types of code, and each codes are doing different kind of things. So one, and this conceptually they call it a namespace. Okay, so MNT namespace is creating mount. Simple. PID namespace is creating PID tree 0, 1, 2, 3, 4, like this. IPC also taking care of the some of the network namespace also taking on the network. CPU and memory device is taken care of by the C groups libraries. Now the question was, what is a mount? So mount simply means, understand this, mount simply means root file system, boot file system, user file system, and application file system. So all together is coming one mount. Now you want to simplify this. What is a root file system? So say there is a one hardware which is called disk. Where is that? Just a second. So there's one hardware which is disk. Here you have a hardware. Now this disk, typically understand this is this disk you can create a multiple VM. Let me reset this. How can we reset this? Oh yeah, is there? Okay, so this is the disk you have in a hardware. Okay, and now typically you have a virtualization tool, and this disk is shared via multiple VMs to create a different disk here. One disk, two disks. These are the VM. Okay, disk 2, disk 3. So this disk which you see is basically is from this hardware, right? So same hardware, but here you see separate one. Correct? Here you see C drive or OPT. Here
Hmm.
also you see C drive, OPT. So this what you see here is called mount. Okay, mount from the physical drive. In Windows we have a C drive, right? It's a mount.
Yes.
When I define what is a mount, so it contains four kind of file system. Okay, four kind of file system. Now you'll say what is a file system? So I think you know that file
Yeah, file
system.
system we know. Yeah, yeah.
Yeah.
File system we know.
So I
So
need to remind you.
one
Just
one thing I just need to ask, like the containers which you have, like a previous diagram which you showed us, the containers we have, like that is mount, one is PID and one is network namespace contained. It is just like a box which is containing all these data. I mean all these components together, and
right,
this we can create multiple times to serve like multiple applications, right? That is
right,
what.
right,
Okay, okay, okay,
right.
okay. Got it.
So let me
Understood.
simplify more. This mount contain four kind of file system. You see, this is the root file system. You
Yeah,
see,
understood. Yeah. Hmm.
yeah, and then you have a boot file system, which is a kernel. Okay, my bad. This is the kernel. Kernel is running in your compute when you run this. Root file system, which you see that here. This is the one which I'm showing you, hovering over. And then user file system. Actually, let me put it up. Let me show you immediately. User file system is this one. Every users is having their own file system. Look at this. This is the my user file system. Belongs to the user. Right? And now last one is application file system. What is application? So typically in my computer, I have installed multiple applications, right? So let me show you. C drive. Oh, CD, C. Sorry. Why typing? So CD tools. Typically, I installed many applications in the CD, C tools or some program files and all. And you see that multiple file systems. Let me show you. See here. This is the Apache one application file system, right? So when you want to run any applications, then you have a kernel. Then you have a root file system, some user, some application. Example, kernel, root file system. Let's say Ubuntu is a root file system. Okay, based on the Linux kernel, and then user may be root. You are running application Apache. Maybe you want to run some more applications. Kernel, CentOS, some user Rajesh, you want to run MySQL. So this is the whole things together is become one mount, one root file, one file system. Got it? Which has applications. Got it?
Yes, got it. Yeah.
Okay. So this is the
One more question I have. Like, I mean, still many of the companies, like the company which I am in, they have VMwares, and they have a mix and match kind of, like they have this Docker also, container also. So, basically, beneficially wise, like Docker container is much capable. So, why people are still there with VMware as of now? Yeah.
okay. So see here. This is a transition. Earlier we were running data center in physical server. Then we migrated to VM. Now, when you say VM, then many options are there. VMware, if you want to create a private data center, you can go to AWS also. There also you get a VM only. Azure also, and Google Cloud. These are the major one. But now we are saying, hey, these are the platform where we run a VM, which is not a cost effective. Just now we discussed, right? Which is not a cost effective because it's
Yes,
consume
yes.
lots of CPU, RAM, and operating system costs also, and time is also crucial because nowadays we all run based on the SaaS, PaaS, and all kind of things. So then we started migrating from the VM to the container. So this migration, this transition is still is in progress for many organizations. Many organizations have transitioned it already. So it depends why they are using it. Depends on the organization's running policies and things like that. So if they have not migrated, they must be having some business use cases or some limitation, some cost involved. Maybe you, but most of the people, most of the organizations which I have come across, they have migrated to containers and Kubernetes. So that is stuff. Okay, so now what I was trying to help you out, some of the questions which I wanted to explore was, what is Docker? I hope you got the answer. Now, why Docker we are needed? Okay, and then what is container? These are the three fundamental questions which uh, I wanted to discuss. After that, how Docker works. This is the question we should target. So something like a Docker architecture also we can call it Docker architecture. So how Docker works. So in every architecture we are the person who always there. Okay, and we interact with Docker client. Okay, Docker client. There's a one executables which is there in laptop. You install the Docker, right? And then you get a Docker client. And Docker client, are you able to hear me? Because I see some network issues on my pop-up. Am I audible? Am I audible? Hello?
This
Are you able to hear
conference will
me, right?
now be recorded.
Hello?
Yes, we can hear you.
Okay, cool. So here I was discussing about the how Docker works or Docker architecture. So in a Docker architecture, we are the one who always talk to the client. We send the instruction, commands, and all to the client, Docker client. And Docker client send the instruction to Docker server, Docker D we call it, daemon, whatever you call it. Okay, and then Docker daemon send this instruction to container D. Okay, and container D send this instruction to kernel to get this all work done. Okay, So this flow is clear, right?
Yeah, yes. So what is Docker client? I mean,
Yeah. So this Docker client and Docker server, this is a Docker engine. Okay, this is the one software which we installed. So when we say Docker, actually we are talking the Docker engine. Docker is a company name. They have a multiple products. One of the most popular product is Docker engine. So when we install Docker engine, we get a client and we get a Docker server, which is running in your VM or physical server. So client is nothing but a command line. For example, let's say Git is a command line, right? Same way Docker will become a command line when you install the Docker, something like that. So this is the client.
okay,
Got it?
got it. Yeah.
So it's a client to Docker-D and then container-D. So this is how it works. Now, let's say if you want to learn Docker, what are the components you have to learn? What are the things you need to know? So primarily you need to know four components. Okay. One is Docker engine. You need to install it. It's very simple. One command, you can install it. I'll show you the demo. So Docker engine, you need to install it. After that, once you install the Docker engine, you need to get a Docker image. Okay, Docker image. And then from where you get the Docker image, but what is a Docker image, I'll discuss in a few seconds. And Docker image, you will get it from Docker registry. What is registry? I'll discuss. And then the moment you run the image, you get a Docker container. Okay. So these are the four components only you need to know in Docker. So Docker engine, so needed to install. This is the one command line. It will be installed actually. I'll show you that during the demo. So when you install the Docker engine, you get these two executables. This is the service, by the way, which runs and talking to the containers, containerd and kernel. Okay. Now the most important question is Docker image. What is Docker image? So let me ask you one question. Have you worked with a VM image? VM image?
I mean,
Hello?
like the VM, which will have some operating system and
Correct.
all the
Yes. So
configurations.
remember
Yeah.
that VM image, create a one mount and then mount VM image. You have a this one. Any one VM image, let's say you might have Ubuntu, Windows, CentOS, or any VM image you might have used in the past. In a cloud, we call it AMIs, right? In AWS, we call it AMIs or something like that. So your VM image has a boot file system. That means kernel also is there. Root file system, user file system, application file system. Okay, so these are the four file system one VM image will contain. Now coming back to the question for Docker image, simplifying this, Docker image will have only this one, no operating system. That means you will have a root file system, example Ubuntu, CentOS, Windows root file system, user Rajesh, root, administrator, whatever it is, Apache, and applications, it can be Apache, LS, VI, Python, Java, this, that, all these things. So your image will contain your applications plus prerequisite users and root file systems. Right? Understood?
Yeah.
Now the question is, where do we get this image? So this image you created your own, which I'll show you during the demo. But most of the time we download it from the registry. Okay. So what is a registry? So registry is a concept. Okay. Registry is a concept. It's like a GitHub is a registry. GitHub is a registry. What you have on the GitHub? Repository. What you have inside a repository? File systems of the application source code. So same way, Docker registry is a one concept, and there are plenty of registries are available. Every cloud companies, they have their own registry, but there's one registry which is very popular and which is called Docker Hub. This is a very popular registries. Okay, default registry. What you can find it here, you can find lakhs on lakhs of images, free images. You see, a lot of images. You can search for it also. Earlier they were showing the number of images, but now they have changed the UI. So what do you want? So many images you have it. Search for it. What kind of image you want? So you want Python image here, and official, non-official, user contributed. Even you can create account just like a GitHub, create a repository and push your images once you create it. Okay, Python you have PHP image, right? You have here Ubuntu image is there. Ubuntu image only, base image, CentOS image, Windows image. So all this image are available to use it. People have contributed. It is official, some verified, some sponsored, and many more. So this registry is where from you get the Docker image. Make sense? I repeat, this registry hub.docker.com, which is the most popular and a default, but in the world there's so many registries are available. In fact, you can host your own registry also using some of the software like there's one software which is called Docker Registry or Artifactory or Nexus. These are the one we can use it. AWS we have a registry, their own registry. Azure they have their own registries. Right? So this is the Docker registry. Is it clear?
Yeah. So Rajesh, we can create our own images, right? I mean, these are the like defined images for like Python and other resources.
Right. Yeah. Yes. You can create your own registries also, and then you can create your own images also. And you define what you want in images. You say, hey, I want Ubuntu. I will have one X user, and inside that I will install my applications such as Python, PHP, Java, Java plus Tomcat, Java plus Tomcat plus application. So anything you can define, customize image.
Okay.
Okay, and the last thing is Docker container. So what happens? Understand that when you run image, yes, this image, you download it and then run this. So what happens? So when you run image, one user get created, sorry, one mount get created from image. Mind it, this mount which I was talking about all the time, from image. That means whatever you have an image, you will see inside a container running. Okay, I repeat, whatever you have an image, you will see inside a container running. So one mount from image plus one PID and plus one network, and then after that this all resources get attached to one user, and that's your container is equal to, that's your one container. Got it?
Yeah.
So these are the few things which we have to know. Okay, so now most of the understanding part is done. What is Docker? Why Docker? What is container? And how Docker works, Docker architecture and components of Docker. Now what we need to do, nothing great. We need to install Docker engine, and then I need to show you how can a Docker create, start, stop, restart, pause, unpause, kill, and remove a container. So these are the things I need to show you because Docker is primarily used for all these activities only. Got it?
Yes.
Okay. So let's have one break for 10 minutes. And then once we come back from the break, I'll show you the demo. See you.